we're going to take a look at a couple examples. The first one is verifying inverse functions. I give you two functions here, and we're supposed to verify if f of x and g of x, if they're inverses of each other. So the first rule that we've gone over is composition of f of x, g of x, and that has to equal x. We have to check that first. But we also have to check g of f of x, and that has to equal x. Now, this is all comes from our visual of a reflection in the line y equals x. So, in reality, this is really y. It's a composition of two functions, but we're really saying y equals x, and we're just verifying that y equals x. And this is another type of function in reverse, but it's still verifying if y equals x. So we want to take a look at the algebra work for that. First step we're looking at is we're taking a look and we're inputting the function g of x. So the input for f is going to be g of x. So I put in x plus 7 over 4, just to note that that's our input. So now we take f of x, which is 4x. So that's our input, so we have to put the new input in. The input in this case with a composition is a whole function g minus 7. And all we're doing is doing a little bit of algebra work. We can see that 4 divided by 4 is 1, and then leaves us with x plus 7 minus 7. When all is said and done here, we get x. So that one checks out. The other one we have to check is g of f of x composition. Same idea. We're taking the function g and we're going to input 4x minus 7. So now we have the function x plus 7 over 4, and we want to input this new function f. So let's put that in parentheses to say that whole thing is the input right here. New input is that function plus 7. We're going to finish g equation and get that as our new function. When we simplify here, we're going to see negative 7 plus 7 and have 4x over 4, and that'll reduce to equals x. So indeed, g of x is an inverse, so we can say g of x is equal to the inverse of f of x. This is not an exponent, it's just notation for inverse. So this example is a little different. We're only given one function, f of x, and what we want to do is we want to find the inverse of it. So in this case, we only have one function, whereas the last one, we were asked to verify that these two were inverses of each other. So now we're given the task of finding what it is. We've gone over these 3 steps in class in our notes, and what we're going to do is follow those steps. So we're going to replace f of x, the whole thing, with a y equals 4x to the third minus 1. And then we're going to interchange them, so we're just going to switch them. So x equals y is the whole idea. So we have 4y to the third minus 1. And now we're going to solve for y. X plus 1 equals 4y to the third. Our next step, divide by 4. Now we're given this x plus 1 over 4 equals y to the third. We have to remember our rules for solving for y here. So since it's y to the third, we want to take the cube root, because that property is going to get us down to y, isolated. And whatever we do to that one side, we have to do the other. So we're going to take the cube root of x plus 1 over 4. And in this case, we're going to take that as our inverse. So we can translate this to be the inverse of the function f is equal to the cube root of x plus 1 over 4. And that's one example of finding the inverse of a function. So let's look at another one. Same idea. Go through the steps. Let's interchange, or let's start with the first step where we replace f of x with y. So we're going to say y equals 3x minus 1. Second step, y equals x. So let's interchange them. And now we can start to solve for y. So in this case, we can add 1 to both sides. And we have x plus 1 equals 3y. And from here, it's pretty straightforward to get y isolated. Divide by that 3. Now we have x plus 1 over 3 equals y. So we can say that the inverse function of x, f of x, is x plus 1 over 3. So here's a little tougher example, algebraically at least. So let's start with step 1. Y equals 2x plus 1 over x minus 3. Let's interchange. X equals 2y plus 1 over y minus 3. And then we start to solve for y. So first thing we can do is we can take the denominator on the other side, and let's just make it so that we have multiplication y minus 3 to both sides. When we do that, let's distribute for a moment and say x minus 3x equals, we know that's going to divide out, we'll have 2y plus 1. So in this case, we have to say, alright, now we've got two terms with a y in it. So the strategy here is, let's get them to be on the same side. So I'm going to subtract the 2y and add the 3x. So when I do that, I get xy minus 2y. Then move the 3x over. We have positive 3x on the right side plus 1. Now, we have two terms with y in it. So let's turn that into a factoring problem. So now we have x minus 2 times y equals 3x plus 1. And now we can easily solve for y, because we can take that as a whole term and divide it. That's 1. Y equals 3x plus 1 over x minus 2. And that's equal to our inverse. So I've taken this inverse by tables, and you're given two tables, one for f of x, one for g of x. But this time you're not given an equation, you're just given particular coordinates that are on the graph of these functions. So the first problem down here, I say f of g of 4. Well, we can look at the table and we can see what g of 4 is. If I look, g of 4, so when I input 4, my output is 2. So really, I'm saying g of 4 is also equal to 2. So now we just have to look, and our new input is 2, but it's the input to the function f. So now we can look at this table for f of 2, and we know when you input 2 into f, the output should be -1. Let's look at 1 in a different notation. So g composed of f of 1. We know this is the same as saying g of f of 1. And now we're kind of like in the same process as the last one we looked at. So the first input is f of 1. So we can look at our table and say f of 1, well, we know that's 5. So g of 5, since that's the value of f of 1, and now our new input is 5, but it's saying it's the input for g. So we can't see that in here. But if there were a value, let's say 5 was 6, then we could easily say g of 5 equals 6. So you're looking at the table of values that they give you for this particular problem in the homework. Another wrinkle they might throw at you is looking to see what the inverse function is. So if I said x and I made a table for the inverse of function f, well, we know that y equals x is the reflection. That's the idea of inverse. So basically what you can do is you can say now the outputs from f are the inputs for the inverse. Where did I get those? I get those from the output of f of x. And the input of f of x now becomes the output for the inverse. And that's the idea with tables. So let's look at a problem. This one says the inverse of f of g of 1. So let's look and see what the output is for g of 1. So g of 1, we input 1, and the output is 1. So now we have this idea of g of 1 is equal to 1. So that's going to be the input for the inverse function now. That's how we read that. If this is the input, what's going to be the output? So f of the inverse of 1, and we'll look at the table, negative 1. So just by reading the table, we can see what the output will be.